All right, so for this one, we're doing more of the same. We're trying to practice solving equations. So there are different ways that we can solve them. We can use hangers. We can use the distributive property. We don't have to use the distributive property. So we're trying to find the easier strategy to use. So I'm going to start with my first equation. I have negative 3x plus 6 equals 21. So I'm going to finish drawing my diagram. So I know I have a positive 21. So I'm going to zero out. So that means I'm going to add negative ones. So that I can do that. And that would be 6 negative ones. So that means I'm left with, I got to cross out all my zero pairs. So that means I'm left with over here a positive 15. I know it's positive because the sign of the larger absolute value is positive. Signs are different, you subtract. So now I have to take this 15 and split it up into 3 equal groups. So 15 split into 3 equal groups is going to give me 5. Okay, now the problem is a negative 5, we've got to see if it's going to be a negative 5 or a positive 5. Because right now, these are all negative 5s. So let's try a negative times a negative is going to give me a positive. That'll give me a positive 15. So x equals a negative 5. Let's prove it over here by solving it traditionally. So negative 3x plus 6 equals 21. So I zero out first. And I get 15 equals negative 3x. If I multiply by negative 3, I have to divide by negative 3 because I want to find for just one x. Positive divided by a negative is going to be a negative, and I get negative 5. Signs are different. The answer is negative. All right, so I'm going to draw my hanger. So instead of drawing out each individual cube like I've been doing, I'm going to have to start making them a little bit easier. So that's negative 45. Then I have 5 y's. And I have plus a positive 10. All right, so I have to zero it out. So that means I'm going to have to add a negative 10 here. If I add a negative 10, I have to add a negative 10 on this side to keep it balanced. So now I can create my zero pair. And I'm left with negative 55 on this side. So I'm taking the negative 55 and splitting it 1, 2, 3, 4, 5 different ways. So that means that each y is going to be equal to negative 11. All right, now let's solve it over here. So we got negative 45 equals 10 plus 5y. So I zero out first. I'm left with negative 55 equals 5y. I want to figure out what it is for just one, so I'm going to divide by 5, and I'm left with y equals negative 11. When the signs are the same, the answer is negative. Or when the signs are different, the answer is negative, and I have a negative and a positive. All right, I'm going to draw my pieces in. So I have a positive 16, and I have 2 negative k's. And then on the other side, I have a positive 14. So to zero out, I'm going to have a negative 16 and a negative 16. So that's going to leave me with a negative 2, because when the signs are different, you subtract and take the sign of the larger absolute value. Then I'm going to split it into 2 equal groups, so each one is going to be 1. Okay, so now I'm going to show you how to solve it traditionally. So we have 16 minus 2k equals 14. So I'm going to have a negative 16, because a positive and a negative zero out, and I'm left with negative 2k equals. This says 14 plus a negative 16. Signs are different. I have to subtract, and I get negative 2. So when I multiply by negative 2, the opposite is to divide by negative 2. I'm left with k equals 1. All right, so now I gotta draw my hanger. I have 1/4 m. And that's positive. And then I have a minus 7, so that's a negative 7. This one's a little bit different. Oh, and then I got a negative 3 on this side. All right, so I got to zero out first. So I'm going to be left with positive 4 on this side, right? So now, if 1/4 is equal to 4, then the whole circle would be, if 1/4 of the circle is equal to 4, let's reason this out, then I would have 4, 4, 4, and 4. So the whole circle would be equal to 16. So m has to be equal to 16. Let's see if we're right. So I have 1/4 of m minus 7 is equal to negative 3. We treat a subtraction the same way we would treat a negative. So we're going to add 7 to each side. I zero out. Signs are different. I subtract. I get 4, and it's going to be positive because the sign of the larger absolute value is positive. And I'm left with 1/4 m. Now, if I've multiplied by 1/4, I'm going to have to divide by 1/4, right? 4 over 1 divided by 1/4. So now we can't forget our general rules of keep, change, flip. And I get 16. So m equals 16. That one was different. Let's try another one. So now I have negative 5. And then I have a positive 7. And this time I only have 1/2 of w. Is it a positive w? Yes, it is. Good. This is weird. Okay, so if I want to zero it out, I'm going to, I want to get rid of the stuff that's on the side with the variable. See how I so quickly got used to the pattern of working left to right? Okay, so I have to add a negative 7. So I'm left with negative 12 is equal to 1/2. So if it's half, if half of this is equal to negative 12, then the other half is also negative 12. So the whole thing would be negative 24. That's what I think it's going to be. W is equal to negative 24. Let's test the theory and see if it worked. So I have negative 5 equals 7 plus 1/2 W. So I'm going to subtract 7, or add a negative 7 to zero out first. Left with negative 12 equals 1/2 W. So now, if I multiply by 1/2, the opposite would be to divide by 1/2. Negative 12 over 1 divided by 1/2. Now I can't forget keep, change, flip, because that's just the rule when you're dividing fractions. And lo and behold, I get a negative 24. All right, so now they're saying 1/3. That's the distributive property. So how could I draw that? I have 1/3 of a group of p minus 1. Maybe it would be better, because remember the idea is you're trying to figure out the better strategy to distribute first, then draw my hanger diagram. So that'd be 1/3 p, and then 1/3 times a negative 1 would be a negative 1/3. So I have 1/3. And then I have a negative 1/3. Okay, and then over here I've got negative 4. All right, so to zero it out, I'm going to have a positive 1/3. So that means I have to add a positive 1/3 over here. So that leaves me with, signs are different, I have to subtract. So I'm going to be left with 3 2/3. It's going to be negative. So now, if one spot is a negative 3 2/3, then that means 3 spots, oh goodness, would be 3, 6, 9, so that's 9 for the whole numbers, and then 2, 4, 6, 6/3. So if I reduce that and changed it around, so 3 goes into 6 2 times. So I get negative 11. So I think it's going to be equal to negative 11. If the whole disk is going to be equal to negative 11. Let's try solving it over here. So 1/3 times p minus 1 equals negative 4. So I get 1/3 p minus 1/3 equals negative 4. So now I have to zero out. So if I have a negative 1/3, the opposite would be to add a third. So I know when my signs are different, I subtract, and I get 3 2/3, and it's going to be negative because you take the sign of the larger absolute value, and then I have 1/3 p. Now, if I multiply by 1/3, the opposite would be to divide by 1/3. So I'm left with negative 3 2/3. So I have to change this around to an improper fraction so I can solve it. 3 times 3 is 9, plus 2 is 11. So negative 11/3 divided by 1/3. So I'm going to use my calculator, or I'm going to use my keep, change, flip, because that's my strategy. and I get negative 11 over 3 times 3 over 1. So negative 33, oops. Negative 33 divided by 3 leaves me with negative 11. All right, last one before the cool down. So now I have 1/2 of A plus 7. So we figured out it was better to distribute first than it is to try and go ahead and draw your diagram. So that's 1/2 A, and then 1/2 times 7 would be 7/2 is equal to negative 12. So let's draw that out. So I have a half, right? And then I've got 7/2. So I'm going to use red because it's positive. So then I have a negative 12. All right. So now I have to zero out. And I think I'm going to change this into a decimal just to make it easier on myself. So 7 divided by 2 is 3.5. All right, 3.5. Okay, so to zero out, I'm going to have a negative 3.5. So then I'm going to have a negative 3.5. So that zeroes out. And I'm left with a negative 15.5 because that's signs are the same, so I can add. So that means this side is negative 15.5, which means this side is going to be negative 15.5. So I think my answer is going to be, what, negative 31? Because I add both of them together. I think that's what my answer is going to be. But let's test it and see if we're right. So over here, I'm going to solve it traditionally. So I have 1/2 A plus 7 equals negative 12. All right, so I've got half of A, and then half times 7 is 3.5 equals negative 12. I zero out first. So I have 1/2 A equals, signs are the same, so I add and I get 15.5. All right, I'm doing great. Zeroed that out. So now I'm left with 1/2 A. So if I multiply by a half, I have to divide by 1/2. So I'm left with A equals 15.5 over 1 times 2 over 1. I did keep, change, flip. So I get, oops, I forgot to carry over my negative sign. Yikes. Signs are the same. It's going to stay negative. So I have to keep it there. So now I get 31, and it's going to be a negative 31 over 1. Crazy. All right, so now I need you guys to do the same thing. You're going to solve these two problems. You can solve them traditionally, or you can solve them using a diagram. And then I need you to submit your assignment. If you need help, there's extra practice on Khan Academy. Mr. Morgan does a great help video, and then your study buddy, or set up an appointment on Calendly. I tutor on Monday, Tuesday, and Wednesday. I hope you have a great rest of your day. Bye.